Let's look at one more example called the Koch Snowflake. We can build up this shape by adding two sides of an equilateral triangle to each line segment at each step of the process, repeated infinitely many times. The fractal part of this image is along the edges. We can take one such edge to see how it is built up at each stage. Notice that this is being constructed by adding line segments, which are one-dimensional components, at each step of the way. Yet, the dimension of the fractal object turns out to be 1.26, which is close to a one-dimensional object, but with some part of it in a little bit of area. Somehow, by adding one-dimensional line segments, they've become crumpled up into a higher dimension. Additionally, if you look at each stage, you'll see that each line segment is actually augmented to include an extra 1/3 length. So at each stage, the length of each part of the fractal grows by 4/3 in length, which means that the total length of the perimeter grows by a factor of 4/3. This pattern continues toward infinity. So 4/3 times 4/3 times 4/3 times 4/3 and so on. But that means that the total length of the crumpled perimeter of the snowflake becomes infinitely long. It can also be found that the interior area that is enclosed by the snowflake is equal to 1.6 times the area of the original triangle in the first step. If we assume the original triangle had an area of 1, then paradoxically, an infinitely long perimeter surrounds a finite area of 1.6.